one more time.
Aha!
Brand was an Hamburg alchemist who discovered phosphorus during his attempts to turn base metals into gold. Evaporating urine produced ammonium sodium hydrogen phosphate, which yielded sodium phosphide upon heating. When heated with carbon, this decomposed into white phosphorus and sodium pyrophosphate, as seen from the equations. In 1680, Boy created a piece of paper with phosphorus, with a separate splinter of sulfur-coated wood. When the wood was drawn through the paper, it would burst into flame. Boy's method of isolating phosphorus was more efficient than Brand's, and this is the following equation. 1.5 centuries later, Charles Surya made a match using white phosphorus and potassium chlorate in the match head. However, the phosphorus was deadly. Many people developed a disorder known as phossy jaw. Children who sucked on matches developed skeletal deformities. Phosphorus factory workers got bone diseases. White phosphorus was replaced by red phosphorus in 1844. It was formed by heating white phosphorus to 250 degrees Celsius or by exposing white phosphorus to sunlight. Red phosphorus has a lower flash point and is safer. It does not ignite in air at temperatures below 240 degrees Celsius, whereas white phosphorus ignites at about 30 degrees Celsius. From the use of red phosphorus, different types of matches were created. The first is the strike anywhere matches. These matches contain both red phosphorus and potassium chlorate in the match head, which will ignite when struck anywhere, even when matches rub in the box. The second is safety matches. The match head contains potassium chlorate while the surface of the box is lined with red phosphorus. Thus, the matches will only ignite when struck against the box. Let's move on to the thermochemistry of matches. Energetic stability refers to the energy level of the substance. The lower the energy level, the more energetically stable it is. As such, exothermic reactions are energetically favorable reactions. Kinetic stability refers to the activation energy required for a substance to react. The higher the activation energy, the more kinetically stable it is. Most endothermic reactions are kinetically stable, but some exothermic reactions can be kinetically stable too. In matches, the reaction between red phosphorus and potassium chlorate is an extremely exothermic reaction, which makes it energetically favorable. However, the reason why matches don't spontaneously ignite is that they are kinetically stable. Heat from friction is required as activation energy before the reaction can occur.
Another way to look at the chemistry of matches is using Gibbs free energy. Gibbs free energy is made out of three components: enthalpy change, temperature, and entropy. The equation is delta G equals to delta H minus T delta S. It determines the spontaneity of a reaction. If the value of Gibbs free energy is negative, the reaction is spontaneous. If the value of Gibbs free energy is 0, the reaction is at equilibrium. If the value of Gibbs free energy is greater than 0, the reaction is non-spontaneous. A spontaneous reaction increases the total entropy in the universe.
So, for a reaction to be spontaneous, the Gibbs free energy must be negative. From the table below, you can see the possible cases for matches. The matches do not light up on their own at room temperature because Gibbs free energy is positive. However, when we strike the match, we generate enough heat through friction such that T delta S is much larger than delta H. Therefore, Gibbs free energy is negative and the reaction is spontaneous. The reaction increases total entropy in the universe.
boys, two men, serving 2 years for our nation, our country, with blood, sweat and tears. We'll be marching on with pride and glory, because we love our land and want it to be free. From our boys, two men, serving 2 years for our nation, our country, with blood, sweat and tears. We'll be marching on with pride